All right, our last section in chapter 8 is on solving radical equations. And today's goal is to solve radical equations in various forms, but each radical form uses a different process, and so you might have to come back to this video and remind yourself how each problem is done. All right? Solving is the process of isolating the variable. So we're going to just be isolating the variables today, but it'll be the first time that you will have to eliminate radicals, probably ever. I don't know if you've ever had to do that in the past, but you are going to have to do it. And if you remember PEMDAS, please excuse my dear Aunt Sally, is your order of operations. And with exponents here, its radical goes right there. So it's going to be, please excuse my ridiculous Aunt Sally or something like that. You got to add to it. But that's where that's where radicals end up in your typical PEMDAS. When you solve for these, it is possible that you get what's called an extraneous solution. An extraneous solution is a solution that you get when you solve, but when you plug it back into the original equation, it makes an imaginary, non-real answer, or it just doesn't work. It's called an extraneous solution. So it's a solution that is not an actual solution. So in all of your problems, it's going to say solve for it, and then it's going to say check for extraneous solutions. And I've got an example here where I solve for one, and then it actually is an extraneous solution. So let's take a look here. Here's the original problem right here. I'm going to solve for x, and the x is locked in this radical. Add the 2. You're going to add the 2 over to this, and you're going to get a 2 equals this. Then you're going to square both sides. You're going to square this side to get rid of the radical, and you're going to square this side to get rid, not get rid of anything. You're just going to square it to a 4. Then from here, you're going to subtract a 7 to get negative 3 equals 3. Then you're going to divide by 3 to get x equals negative 1. So your solution here is x equals negative 1. That's the solution to your problem here. Now, if I take this solution, and I wrote here, is the solution actually a solution? We actually will plug it back into the original equation. So this guy right here is just the original equation without the parentheses that I added. I plugged in the 1, and I just started simplifying it down. 3 times negative 1 is 3. Negative 3 times 7 is 4, or plus 7 is 4. The square root of 4 is 2, and 2 minus 2 is 0, and 0 does not equal 4. So when you plugged it back into the original equation, it actually did not make a true statement. Therefore, we call this an extraneous solution. An extraneous solution is a solution that is not actually a solution. So thus, the answer is not negative 1, but no solution. Okay, does that make sense? Okay, solve it, check it. That's it. Solve it, check it. So let's do it here. So I'm going to solve this one for y by first adding 2 to both sides. We get 3 is equal to rad 2y minus 7. Then, to unlock the radical, we're going to square both sides to get 9 is equal to 2y minus 7. Add 7, 16 equals 2y. And then divide by 2 and you get y equals 8. All right, so this is the solution, but we have to check whether it literally is a solution. We'll go 1 is equal to the square root of 2 times 8 minus 7 minus 2. 1 is equal to square root of 16 minus 7 minus 2. 1 is equal to 16 minus 7, which is 9er minus 2. And 1 is equal to 3 minus 2, and 1 is equal to 1. And we'll go ahead and check here. And it does indeed is true. It is true. Therefore, 8 is a solution. All right, I want you guys to do letter B and letter C. All right. I think you guys got a chance to do this. So we're going to do reverse order of operations now that I've corrected myself. So we're going to subtract 1, subtract 1. This gives me 2. Square root of 2v plus 12. We'll square both sides to get 2v plus 12 is equal to 4. We'll subtract 12 from both sides. We get 2v is equal to negative 8. And we get v here is equal to -4. If we plug that back in, so this is, by the way, this is our solution. So we're going to plug that back in. Square root of 2 times -4 plus 12 plus 1 equals 3. Now we're going to use order of operations as spelled out in PEMDAS. Square root of -8 plus 12 plus 1 equals 3. Square root of 4 plus 1 equals 3. 2 plus 1 equals 3, or 3 here equals 3. So that checks out. All right, so that is a solution. All right, let's continue here. Add 1, add 1. So we get -2 is equal to rad 4v minus 20. We'll go ahead and square both sides. Positive 4 is equal to 4v minus 20. Add 20, add 20. 24 is equal to 4v. Divide by 4. We get v here is equal to 6, right? All right, so this is our solution. We'll plug that back in, so -3 is equal to square root of 4 times 6 minus 20 minus 1. -3 is equal to 24 minus 20 minus 1. -3 equals 4 minus 1. -3 equals 2 minus 1. And -3 equals 1. So that's a problem, right? Did you get a problem there when you checked it? Okay, so what does this tell us? It tells us that's not a solution, therefore it's no solution. All right. Okay, problem type 2, 3, and 4, so that you can see that these are essentially different topics. There's 3 different topics on this page. How we do this topic, either the 2 big radicals are on the same side or the 2 radicals are on the opposite sides. This is a better situation here because you don't have to do the move. But you can't just take the radical off of everything. You can't just square these. You can only square the entire side. You can't square individual pieces of a side, just the entire side. So if I square this whole side, then I have to do some foiling, and that's going to be a lot of work. We're actually going to have to do some foiling down here anyway, but in this case, let's avoid it. So what we're going to do is we're going to add 7w plus 6 to both sides. That is radical 7w plus 6. 5w plus 16 is equal to 7w plus 6. Now we'll square both sides. Now we can square both sides without having to do any kind of fancy foiling, leaving me with 5w plus 16 equals 7w plus 6. And now it's just strictly solving it. So combine your w's together to get -2w plus 16 equals 6. Subtract 16. -2w equals -10. Divide by -2, and you get w equals 5. That is your solution, but is it a solution? Let's check our work. So we're going to go with the original equation. So square root of 5 times 5 plus 16 minus 7 times 5 plus 6 equals 0. Square root of 25 plus 16 minus square root of 35 plus 6 equals 0. Square root of 41 minus the square root of 41 equals 0, and so 0 does equal 0. So this checks out. So that's just checking for extraneous solutions. All right, you guys do letter B. Letter B, letter B. Okay. So this one's already set up for you, so you can just strictly square it right away. And that would give you 6u minus 15 is equal to 4u minus 3. We'll subtract the 4u, subtract the 4u. We'll add the 15 this direction. A lot of times I like to do steps together. So this is 2u is equal to 12, or u here is equal to 6. Does it check out when you did it? It does? All right, let's do it anyway for the camera. So square root of 6 times 6 minus 15 is equal to the square root of 4 times 6 minus 3. So this is square root of 36 minus 15 is equal to 24 minus 3. Okay, 24 minus 3 is 21. And 36 minus 15 is also 21. So square root of 21 does equal square root of 21. Therefore, this is a legit solution. Okay, fair enough? All right. Now, we only have a radical on one side, and the other side is a variable. And this is going to cause us to get a quadratic, which needs to be factored. So when I first go to square both sides to get rid of the radical, I end up with u squared is equal to 3u plus 10. And because I have a u squared and a non-squared u, I need to clear aside, factor, use zero product rule, and get two solutions, and then check both of those solutions. So let's do that. So let's subtract 3u, subtract 3u, subtract 10, subtract 10. Okay, so none of these are all like terms. So I end up with a 0 on one side. None of these are like terms, so I'm just going to go u squared minus 3u minus 10 and just use that. Factor these. What are factors of 10 that add to 3? How about negative 5 and 2? So u and u. So we end up here with u equals 5 and u equals negative 2. So we have two solutions, guys, now. So that's interesting. Sometimes none of them are solutions. Sometimes both of them are solutions. And sometimes one of them are solutions. So one, none, or both. Okay? So we got to check them both. So we'll plug it into the original equation. So 5 is equal to square root of 3 times 5 plus 10. 5 is equal to square root of 15 plus 10. 5 is equal to square root of 25. 5 is equal to 5. All right, so that one checks out. So we're good on u equaling 5. The other one is negative 2 is equal to square root of 3 times negative 2 plus 10. Negative 2 is equal to square root of negative 6 plus 10. Negative 2 is equal to square root of 4. Negative 2 is equal to 2. So this one has an issue. Negative 2 is not literally equal to 2. Therefore, this is not a solution. There's only one, count them, one solution in this scenario. All right, you guys do letter D. All right, so we're going to square both sides. So we get u squared is equal to 12u minus 27. We're going to clear a side. Now, I'm not going to show that I subtracted 12 and added 27. I'm just going to move it to the other side and flip the sign. So u squared minus 12u plus 27 is equal to 0. That's good enough. Now we're going to factor this. What are factors of 27? That add to 12. I believe -3 and -9 would work. So u equals that. Therefore, our solutions are u equals 3 and u equals 9. Is that the same solutions you guys got? Great. All right, so now we are going to plug those in. So 3 is equal to square root of 12 times 3 minus 27. 3 is equal to 36 minus 27. 3 is equal to 9. 3 is equal to 3. That checks out. So the first one checks out. 9er is equal to square root, I did say 9er, 12 times also 9er minus 27. 9 is equal to, what is 12 times 9? Okay, thank you. 108 minus 27. 9 here is equal to 81, and 9 is equal to 9. So in this case, both of these checked out. So we had only one check out over here, but both of these checked out on the right-hand side. All right, this one, I think this one is the most difficult of them. I wouldn't say it's like terribly difficult, it just is a little bit difficult. All right, because you have a perfect square, a square root equals a square root and then a non-square root. And you can't just square all three of those parts. And I know we're gonna get to the test and our quiz, and you guys are just gonna square those and move on, but you can't, and it's gonna give you the wrong answer. All right? What you can do is square the whole side like this. So what you'll do is you'll move the smaller radical to the side of the non-radical. So I put the square root of w and the 3 together. You're gonna have to move yours over when you do it. You're gonna have to subtract the radical w over to the left-hand side. I didn't have to do it, so I was lucky. Now, when I square this side, I get w plus 39, but when I square this side, I can't just take the square of those individually. I actually have to write these side by side and FOIL them. I have to write them side by side and FOIL them. So foiling means first outer enters lasts. So w equals, w plus 39 is equal to w times w, which is w squared, plus 3 square root w. It's 3 square root w, there we go, plus 3 square root w, plus 9. Make sure I get that in there. All right, so I'm going to simplify this up. So w plus 39 is equal to regular w plus, I'm going to put these together to get 6 rad w's plus 9. All right, so we still ended up with a radical in there, so it didn't eliminate the radicals nicely. But we're going to go ahead and solve this. And for the examples that I saw, I believe that the regular w actually will subtract out. If you end up with a w here and a w here, and they end up going away. We'll also subtract the 9 while we're at it and kind of save some space. So over here, you end up with 30 is equal to 6 rad w. Divide by 6, we get 5 here is equal to rad w. And we will square both sides. And we end up with 25 here is equal to w. Okay, we should probably check our answer just to make sure. Square root of 25 plus 39 is equal to square root of 25 plus 3. 39 and 25, I believe that is 64 is equal to 5 plus 3. 8 is equal to 8, so that checks out. All right? Go ahead. Yeah. Mm-hmm. All right, so we're going to bring the square root w over, and you get square root of w minus 11 is equal to 1 minus square root w. When you go to square this, you can't just make these perfect. You can't just square this, and square this and be done. You have to FOIL this. So we're going to get w minus 11 is equal to 1 minus square root w and 1 minus square root w. We'll FOIL the right-hand side. So w minus 11 is equal to 1 times 1 is 1, 1 times w, square root w, square root W plus square root W squared, which that'll just make a regular W in a second. One that will zero out with this one on the left. So W minus 11 is equal to 1 minus 2 rad W plus W. Now we'll subtract the W's nicely. They always do that. We're going to subtract the 1 to get negative 12 is equal to negative 2W. Divide by negative 2. We get W is equal to 6. Square both sides, we get W is equal to 36. All right, we think that's a solution. Let's double check. Square root of 36 minus 11 plus square root of 36 equals 1. Square root of 25 plus square root of 36 equals 1. Five plus 6 equals 1, 11 equals 1. Is that what you guys got, or did I miss something here? When you checked it, did you guys get the wrong answer, or did I do something wrong? Do I need to come around? Is that right? So this is not a solution, right? Okay. Okay, I'm just making sure that I'm getting the right stuff here. Okay, so just make sure you mark no solution here, if that indeed I did that right. All right, for this, we have cube roots and quad roots. Quad roots just means fourth roots. And cube roots, by the way, can have negative numbers, but quad roots cannot. Just like square roots, quad roots cannot, because no number multiplied by itself 4 times will give you a negative. So right off the bat here, I already know this one here is going to be no solution, but don't make this out to be this B right here as being no solution, because you can have a cube root being negative. All right, so to get the cube root fixed, we have to cube both sides. This leaves me with U is equal to 64. If I cube this one 3 times, or cube it on both sides, we end up here with U is equal to negative 125. Why don't you guys do C, D, E, and F real quick? All right, we're going to go ahead and cube this one here to give us v here is equal to 27. On this one, we will fourth to the fourth power. We get u here is equal to 3 to the 4. 3 times 3 times 3 times 3. Is that 81? Is that 81? Now on this one, you could make the mistake of fourthing this, and you would get v is equal to 16. The issue is that if you plug 16 back into here, there's no way to get a negative number because it's a fourth root. Fourth roots are always going to be positive. So you'll never get there, even if you try. And then lastly, right here, we'll go ahead and fourth this one here. This one is literally y is equal to 16, and it does work, okay? Fair enough? All right, the last, I guess, whatever number of problems we have, all have what's called rational exponents. And I feel that the best way to handle this all right, so 1/4 root really means to the fourth root. So 2x plus 15 plus 2 equals 3. All right, now all of a sudden it's in the, I guess, in the area of something you would recognize and understand how to handle. Because in the rational exponent, it wouldn't make much sense. So once it's in this format, we'll go ahead and follow reverse order of operations. All right, we'll fourth both sides. Now, when you fourth both sides, you end up with 2x plus 15 is equal to, well, 1 times 1 times 1 times 1 is 1. So that's super helpful. That's nice. We'll now subtract 15. We get 2x here is equal to negative 14. And we get x is equal to negative 7. All right, let's double check that. We'll go fourth root here. 2 times negative 7 plus 15 plus 2 equals 3. Fourth root of negative 14 plus 15 plus 2 equals 3. 1 plus 2 equals 3. 1 plus 2 equals 3, and 3 equals 3. Check. All right, you guys do letter B, okay? Follow that same process. All right, so we're going to go ahead and put this in the fourth root form. All right, so we're going to go ahead and subtract 1. Fourth root of 2v minus 5 is equal to -1. Well, I kind of gave you a softball there. Because you have a fourth root, you can't have a fourth root of a negative number, so you know it's going to be no solution. But you would get a solution if you continued to try to do it. If you forced this, it would give you +1 and you could continue moving on. But when you got your final answer and you tried to plug it back in, it would not work because it fails at this moment. No matter what happens between 2v and -5, whatever happens there, you're guaranteed to end up with a positive number, and that's never going to equal a negative number. All right, so this is no solution. All right, cube roots can also always have solutions. So cube root of 3y minus 8 is equal to 1. We'll go ahead and cube it. 3y minus 8 is equal to 1. Add 8, add 8. 3y is equal to 9, and y is equal to 3. Okay, so 3 times 3, just double checking my work, equals -1. Cube root of 9 minus 8 is equal to 1. Cube root of 1 equals 1, and 1 equals 1. So it checks out. So that is a solution. All right, you guys do letter D. All right, so this would be cube root of 6x plus 4 plus 3 equals 7. Again, I like taking these rational exponents, putting it into the radical form that we all know and love, and that we can do them pretty fluently. So -3 minus 3, this gives me 4 is equal to cube root of 6x plus 4. We'll go ahead and we'll cube it. This is 6x plus 4 is equal to 4 times 4 times 4 is 64. Minus 4, this gives me 60 is equal to 6x, or x is equal to 10. Over here is the cube root of 6 times 10 plus 4 plus 3 equals 7. Cube root of 64 plus 3 equals 7. Cube root of 64 is 4 plus 3 equals 7, and 7 equals 7, so that checks out. That just means that 10 is a solution. fourth root of 6v minus 6 is equal to the fourth root of 4v plus 4. In this case here, we're going to go ahead and fourth both sides. So it's really kind of like that problem that we did previously, where we were squaring both sides. This gives me 6v minus 6 is equal to 4v plus 4. And then we just solve it down. Minus 4v minus 4v plus 6 plus 6. We get positive 2v is equal to 10, or v is equal to 5. We'll double check our work here. So fourth root of 30 minus 6 is equal to fourth root. 4 times 5 is 20 plus 4. So fourth root of 24 is equal to the fourth root of 24. And it doesn't matter what the fourth root of 24 is. We just know they're going to be the same number. And so this just checks it out and says that this is indeed a solution, not an extraneous. All right, you guys do letter B. We're almost done, guys. We're almost done.